Hello everyone, and welcome to the first tutorial in microscopy. And in this tutorial we're going to talk about different types of microscopes. We'll talk about different types of microscopes, and then we'll also define magnification and resolution, and then calculate magnification, object size, and also the image size. So let's get started. So we have two types of microscopes. We have a light microscope and then an electron microscope. If you are a Zimbabwean like me, I'm sure the one that you saw is definitely a light microscope. A light microscope, the one that is cheaper. And then this one, which is called an electron microscope, is too expensive. Right, what's the difference between a light microscope and an electron microscope? That will be covered in another lesson. But in short, a light microscope uses light. So in a light microscope, if we're having our specimen, the specimen that we're viewing on a slide, it's light that penetrates through the specimen. So it is the light that penetrates through the specimen to produce an image. I think it's the other way here with our slide here, and then light penetrating through the specimen, and then the eye will be somewhere here. The eye will be somewhere here. So what is penetrating through the specimen in this case here is light. And then in an electron microscope, what penetrates through the specimen are the electrons, not light. And then I've seen some students confusing a light microscope and an electron microscope based on types of light microscopes. There's a light microscope that uses natural light using a mirror. So this mirror is the one that is reflecting light into the microscope, and then others use artificial light. And then in this case, these ones are plugged to the mains, and then after plugging them to the mains, they have bulbs, and then those bulbs are the ones that produces light. So here the source of light is the bulb. This produces light. And then in these ones, the source of light is the sun or natural light, which is being reflected by the mirror. So both of these microscopes, they are called light microscopes. Not necessarily to say that this one, which is plugged to the mains, is an electron microscope. It is still a light microscope, which is using a bulb to produce that light. So let's move on and talk about magnification. So what is magnification? It is the multiple of the eyepiece magnification and the objective lens magnification. So remember, we have the eyepiece somewhere here. Sorry for the poor diagram. We have the eyepiece lens somewhere there, and then here we have the objective lens, and then we have the stage here. So if we are talking about magnification, we are talking about the product of multiplying the eyepiece magnification and the objective magnification. For example, for advanced level in Zimbabwe, most of the microscopes, they have a times 10 or a 10 times eyepiece lens, and then here you have a 4 times, and then a 10 times, and also a 100 times. A 100 times objective lens. So here, if we're saying that, if we're talking about magnification, we're saying that it is the product of multiplying this eyepiece lens magnification with the objective lens magnification. So if you're using the 4 times of objective lens, it means that the magnification will be 10 times 4, which is 40. And then if you are using the 10 times objective lens, it will be 10 times 10, which is 100. If you are using the 100 times objective lens, it will be 10 times 100, which is 1000 times. And then what does this mean? If you are getting 1000 times, it means that the object is now seen as if it's 1000 times larger than its original size. Right, and then alternatively, we can also say that magnification of an object is how many times the image, is the image. I think I made a mistake here. So we can say that magnification of an object is how many times larger the image is as compared to the object. How many times larger the image is as compared to the object. So if we have an object here, for example, we have this object here, and then this object produces this image here. So if we're talking about magnification, we're saying how many times larger is this image as compared to the object that we're having here. So if we are to produce, for example, 4 of these for us to make this one here, we can say that the magnification in that case will be 4 times. Electron microscopes have a higher magnifying power as compared to light microscopes. So electron microscopes can magnify up to 500,000 times. So whatever you'll be viewing will be its size will be multiplied by 500,000. And then in light microscopes, the maximum that you may obtain is 1,500. Remember, for us to get the magnification, we say the eyepiece magnification times the objective lens magnification. So the eyepiece will be somewhere here, and then we'll be having our objective lens here. Right. The largest eyepiece that I've seen is the one that multiplies 15 times, the one that is retained 15 times. There are those that are retained 10 times, and then those that are retained 15 times. And then when it comes to the objective lens, the largest is the one that is retained 100 times. So if you say 100 times 15, you get 1,500. So the maximum magnification that you can obtain from a light microscope is 1,500 times. So how do we calculate magnification? Magnification can be calculated using this formula. Magnification is equal to image over object. And then in case you might forget, just remember the alphabet. I comes first before O. So it's image over the object. And then if you want to calculate, for example, the image size. So if you want to calculate the image size, you just have to make the image size the subject of the formula here. So you get image size is equal to the object size multiplied by the magnification. And then the same applies if you are calculating the object size. You have to make the object size the subject of the formula, and then you say object size is equal to the image divided by the magnification. The image divided by the magnification. Let's move on and talk about the resolving power of a microscope. So what is resolution? Resolution is the minimum distance apart that two objects have to be for them to appear as separate. So what are we saying here? We are saying that you are viewing something under a microscope, and then as you are viewing your specimen under a microscope, there are two objects that are close to each other. And then if a microscope has a low resolving power, it will be impossible, or it will be difficult for you to see these two as separate objects. So these two will end up being taken as a single thing, or they'll be seen as a single object, yet they are two different objects. So how close are they supposed to be for them to be viewed as separate? So we're saying that the minimum distance apart that two objects have to be for them to appear as separate is what we call the resolving power. The resolving power. So if they are supposed to be extremely close to each other, we can say that the microscope has a higher resolving power, or its resolution is high. And then if it fails to distinguish or to separate these two objects that are close to each other, then we can say that the microscope has a lower resolving power, or we can say that the microscope has a lower resolution. So a higher resolving power means that two objects can be very close to each other and can still appear as separate, as what we are having here. This microscope has a higher resolving power. And then if the microscope has a lower resolving power, these two might not appear as separate objects. Electron microscopes have a higher resolving power or a higher resolution as compared to light microscopes. So the resolving power of an electron microscope is far much higher than that of a light microscope. So this marks the end of today's lesson. See you next time.